Welcome to this lesson. In this lesson, we'll be treating the gas laws and we're focusing basically on Boyles and Charles' law. So let's head into the lesson straight away. So gas laws describe the relationship among pressure, volume, and temperature. So when we talk about gases, there are these parameters that are very important when we discuss about gases. And these parameters are pressure, volume, and temperature. So these parameters are what the gas laws are focused on. So they are hinged to these parameters, pressure, volume, and temperature. So Boyle's law and Charles' law are one of the fundamental gas laws in chemistry. So they try to explain how gases respond to change in pressure and also change in temperature under different controlled conditions. So let's head on to Boyle's law. So Boyle's law states that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. So what this law is trying to state is volume is inversely proportional to pressure. That's the law in simplicity. That the volume of every gas is inversely proportional to pressure, meaning as the volume of gas increases, the pressure will be decreasing. As the volume of gas decreases, the pressure of gas will be increasing. So this law is what is known as the Boyle's law. So this Boyle's law holds true. That's this condition is holds true at constant temperature. So it's not that at every time you expect that okay, when there is an increase in volume, there would always be a decrease in pressure. It's only when it's at that constant temperature that this law would hold true. So the complete law states that the pressure of a liquid is inversely proportional, or the volume of a liquid is inversely proportional to the pressure at constant temperature. So if you don't put this constant temperature, you are actually not completing to state, you're not completely stating the Boyle's law. So it's as I said, the gas laws, they are hinged to these parameters: pressure, volume, and temperature. So each of these laws, both Boyle's and Charles' law, which we'll be seeing later on, they in their laws, they call out these three parameters. So in Boyle's law's case, we say that the volume of a fixed amount of gas is inversely proportional to the pressure at constant temperature. Volume, pressure at constant temperature. Volume inversely proportional to pressure at constant temperature. So mathematically, this law can be written as P equals to K over V, or PV is equals to K. So usually you see it in some cases as P equals to K over V, or P is directly proportional to 1 over V. So that's just trying to tell you that it's inversely proportional, where P is representing the pressure and V is representing the volume, and K is known as the constant for proportionality. So when pressure increases, as I said, the volume decreases, and vice versa. So because of the inverse relationship, it means as pressure increases, volume will decrease, or as volume decreases, pressure would increase. Let's move on to how this law can be demonstrated. The law can be demonstrated by the use of a syringe, or piston. So I think syringe will be the most relatable scenario to explain what this thing means. So when we talk about the Boyle's law says that as pressure increases, volume would decrease. So if we look at this image now, we see that this is a syringe. This is the head of the syringe where normally the doctors will press this end, apply pressure to this end, forcing it off the other way. So what happens to the volume of liquid inside this container? It will keep reducing. So as the pressure at this top increases downward into this syringe, as the pressure is being increased exerted on this syringe, the volume of the container, or the volume of what is inside here, will keep reducing. So this can be used to explain the Boyle's law, or try to give people a visual understanding of what Boyle's law means. That as pressure increases, the volume would always want to, as pressure increases, the volume will always want to reduce. So that's actually what the Boyle's law tries to propagate, or tries to show forth. So the Boyle's law is crucial in many applications, including respiratory machines and syringes, as I just showed now. So let's move on to Charles' law. Charles' law describes the relationship between volume and temperature. It tries to explain the relationship between volume and temperature. So for Charles' law, it states that the volume is directly proportional to the temperature. So the volume is directly proportional to temperature at constant pressure. So we mentioned volume, we mentioned temperature, and we also mentioned pressure. So volume is directly, in case of Charles' law, we're talking about volume and temperature. But in case of Boyle's law, we're talking about pressure and volume. So now, for Charles' law, we're talking about temperature, volume. for Charles's law. Let me put it that way. So volume will be at the end. For Charles's law, we're talking about temperature volume. For Boyles' law, we're talking about pressure volume. So I believe that should be like help you understand that or not mistake it. Boyles' law, pressure volume. Charles' law, temperature volume. So for Charles' law, temperature is directly proportional to volume, or volume is directly proportional to temperature. Either ways, you can say it the same. You can say it either ways. So this relationship now is only true at constant pressure. So volume is directly proportional to pressure. Sorry, volume is directly proportional to temperature at constant pressure. So this law can be written as V is directly proportional to T, or V is equal to TK. As K is being the constant of proportionality. But from what we have here, we say V over T, that we moved T to the other side, so that we have V over T being equals to K. K, as I said, is the constant of proportionality. So what this law means is, as temperature increases, so does volume increases. So as the temperature is increasing, the volume of gases would also want to increase, because these laws are relating to gases. So as volume increases, also temperature would increase. So let's see how this law is being applied. Charles' law can be observed when a balloon expands in a warm room. So I believe sometimes we've observed that sometimes maybe in parties at the beginning, maybe in the morning, balloon, they would seem like as if they were stiff or they were light. But as temperature keeps increasing, the balloon expands, and before you know, you start hearing that some of the balloons begin to burst. So this is because of, as the temperature is increasing, the volume of gas is also increasing. So the gases inside the balloon will begin to expand as temperature hits the balloon. So as they begin to expand, the more they expand, that's what's leading to the explosion of the balloon, because the balloon might not be able to contain their size again, and before you know, they will explode. So that is a vivid explanation for how this Charles law is actually true. So as volume increases, as temperature increases rather, volume also would increase. So once the temperature of the environment is increasing, gases will start expanding. So that's what this Charles law is trying to explain. And this increased kinetic, and as this temperature increases, it leads to an increase in kinetic energy. The gas molecules will begin to move in faster. If you can remember in one of our previous lessons when we were talking about kinetic molecular theory, we said that temperature affects the kinetic energy of gases. So as temperature is increasing, it will cause an increase in kinetic energy, and these gas molecules begin to move more fast, like they will move faster. And as they move faster, they can lead to the explosion of the balloon or the bursting of the balloon, if I'll say it that way. So the increased kinetic energy of gas molecules at high temperature causes them to move more rapidly and occupy more space. So these laws are foundational rather to combined gas laws and ideal gas laws. So the combination of these two laws, the Boyles law and Charles law, is what led to the formation of the ideal gas law. So when you combine gas law and Boyles law together, you will get the ideal gas law. So which integrates pressure, volume, and temperature into one single framework. So these laws, they will help to predict and explain gas behavior under varying physical conditions. That's conditions like varying temperature or varying pressure or varying volume. So these laws, they help to explain gas behavior under these changing physical conditions. So in conclusion, Boyles law and Charles law helps to review how pressure and temperature independently affects the volume of gases. So remember when I was trying to say, okay, Boyles law, I said pressure, volume, and I said Charles law, temperature, volume. So both of them are talking about volume, but now depending on different other parameters as pressure and temperature. So Charles law is mentioning pressure. So Charles law is mentioning temperature and volume. Boyles law is mentioning pressure and volume. So they are both comparing, these two laws are comparing how pressure and temperature affects the volume of gas independently. So mastery of these laws is essential for understanding real world phenomena and also for solving practical problems in chemistry and physics. So with that being said, that will be the end of this lesson. Bye.